All right, how's everyone doing? Hanging in there? Okay, so I have a review for you. I don't think you're going to like it too much, but all it is a list of questions straight out of the packet that you should be able to do. All right, so what you'll want to do, well, let me hand this out, you'll see. There we go. So if you can do these problems out of the packet, then you should have a pretty good time with the test next week. So you need to make sure you go through the packet, and these are a lot of homework problems, so you theoretically have already done them, but I would go through them a few times. Make sure you can do them quickly. I do not think the test will be this long. I just tried to give you a fair sample of what to expect. I'll make the test where it can be hopefully completed in the amount of time you have, which is the entire class. I think on the first exam, time wasn't really an issue for many of you. I don't remember having a lot of people left at the end. So I'll do the same thing on this exam. I'll try and make it where you can finish it. Just remember that on Wednesday I will not be here, which means I will not be in my office before or after the exam. All right, so today we're going to do applications of lines and mixture problems. These are word problems. Students have trouble with this, all right? And then next Monday, all we're doing is reviewing. So I'm going to come in here, and what I'm hoping is that you've spent part of your weekend going through that review, and maybe there's some problems you still just don't get. We can do some more examples, all right? Questions? All right, let's get into these word problems. So these word problems we're going to do today are broken up into two groups. First, we're doing applications of lines, and then we're going to be doing mixture problems. So here they are. So just remember that when it comes to lines, this is our favorite form of a line right there, y equals mx plus b, where if we know what m is, we know what b is, we basically know everything we need to know about graphing the line. All right, so solve the following application problems involving linear functions. Mr. Thompson is on a diet. He currently weighs 260 pounds. He loses 4 pounds per month. Right, 4 pounds per month. So part A says, write a linear model that represents Mr. Thompson's weight, W, after X months. So they want us to come up with some equation that gives you his weight, and X in the problem is the number of months that he's been on his diet. So we start out with saying his weight is equal to, now, what do you think? It's going to look like this, but we're not going to be using X and Y. We're going to be using other letters, whatever they tell us to use here. Here they want us to use W and X. So what is his weight after a certain number of months? What do you think? 260 is where he starts, right? And so his weight would be 260 minus, so every month that he takes off, right, he loses, so subtracts 4 pounds, right? So 4 pounds, but 4 pounds times X. So if he has not started working out, what's X? If he hasn't started working out. So X is like the number of months, right? So if he hasn't started working out, X would be 0. 0, okay? So he has worked out 0 months. If I plug 0 in here for X, then this goes away and you just get what? 260. That's his weight, right? That's what he starts at. After he's worked out for 1 month, I would plug a 1 in here. I get 260 minus 4, so he'd be at 256, right? If he's worked out 2 months, then he's lost 4 pounds twice now. So you're doubling this number. Does that make sense? Okay, so do you all see that that looks like this? Okay, for us, y is w. What's m for us? Careful, the m is the number in front of the variable x. So for us, what's m? -4. So what I need to do to make it look like that is switch the order. Put the -4x in front plus the 260. Then it looks like this, right? This is your m. And then, this was like your y. This was still x. And this is like the b. Does that make sense? So m here for us is -4. B is 260. We clear on that? This is what part A is asking us to do. Write a linear model that represents his weight, W, after X months. So I'm going to box this. I'll put it over here. W equals -4X plus 260. Are there any questions on that part? How I got any of this? Sure? Okay, what's part B asking? After how many months, right, will Mr. Thompson reach his goal weight of 220 pounds? Now, what I don't want you to do is sit there and start subtracting 4, just, on your calculator, keep taking away 4, 4, 4, 4, until you get to 220. Instead, we want to use the equation, all right? So, what are they asking for here? How many what? Months, right? How many months? That's X, right? They want to know what X would be, right? What X needs to be for his weight to be 220. So if I go to this equation, if I replace, so this is part A. For part B, what I'm going to do is I'm going to replace W with 220, and I'm going to let X be what I'm solving for. Does that make sense? So just rewrite this equation. 220 is weight equals -4x plus 260. And now you have a linear equation, right? A little linear equation. You can solve this for x. So how would we go about solving that for x? What would you do first? If you're trying to get x by itself, what's first? You always try and get the term here by itself first. So get rid of this. So how do I get rid of the 260? Subtract it, right? So I'm going to subtract 260 on both sides. I'll do that right here. So I subtract 260, subtract 260. Goes away over here. Now, on the left side, what's 220 take away 260? Is it positive or negative? It's -40. So we get -40 on the left side, and on the right side, -4x. Now you can divide, right? Now to get x by itself, you divide by -4. So divide by -4 here, divide by -4 here. So what's the left side become? Positive 10. And the right side, the -4's cancel, and you just have x. Now remember, x is the number of months, right? So it's going to take him 10 months. $10 months to lose how much weight? 40 pounds. Okay? Does that make sense? All right. All right, let's try the next one. Let's skip number 2. I'm not going to do 2. 2 is not really relevant. Maybe if we have time, we'll go back and talk about it. But all right, Kara uses the linear model f of x equals 20,000 plus 0.3 3x to predict her total salary from achieving a total sales of x. Interpret the slope and the y-intercept in terms of her salary in sales. Whoa, what? Okay. So what they want you to do is look at this and first recognize that this is a linear equation. This does look like y equals mx plus b. M here would be the number in front of x, and b is this number here. This function represents her total salary from achieving a total sales of x. So x in the problem is how much she's selling. We talked about a model like this earlier in the semester. We said, you know, if you sell cars, maybe you make a certain amount for just showing up, and then you make a certain percentage of what you sell. This is basically what's happening here. They want you to just identify what is the 20,000 in the problem, like in terms of Kara and her money. What is the 20,000, and then what is the 0.3? So, what do you think? What is the 20,000? What's that? That's the base amount of money she gets annually. Does it say that? Doesn't say annually. We'll assume it's annually. All right. So this is her salary, her base salary. So the 20,000 is $20,000. We'll call it base salary. That's the money she gets just for showing up to work. All right? Then what is the 0.3? What does it represent?
Like how much commission she gets?
It's like a commission, right? Now, 0.03 really means what in terms of a percentage? That's 30%, isn't it? So the 0.3 really means she makes 30% of her sales. I should say here, Kara makes 30% of her sales. That's all this problem is asking you to do, is to recognize that the y-intercept, right? In this word problem, the y-intercept is her base pay, and the slope of the line represents her percentage. So 0.3, 30% has a positive slope, doesn't it? Like 0.3 is like this. It's not like this, right? 0.3 is positive. You know, if she made 50% of her sales, it would be more, right? So the steeper the line, the higher her salary could be. So that's all they want you to just understand, how that 0.3 is indicative of the percentage of her commission. Okay, any questions? That's it. That's all we have to do for this one. All right, let's look at another one here. All right, the tuition at college XYZ, I've never heard of that college, is $80 per credit hour with an additional $55 student fee. All right? So we all know that when you take a class, depending on the class, it has a certain number of what we call credit hours. Like this class is math 13, 14, right? The 3 in here means that it's a 3 credit hour class. If you took the 14 math class, then you'd be taking a 4 credit hour, which means you'd be in class longer. So here we're here for an hour 15 minutes twice a week. In this class, you're in class for an hour 40 minutes twice a week. So normally in college, the most standard is 3-hour credit, right? That's, most classes are 3 hours. Some are 4. I've heard of some that are 5. Some of the like yoga classes and things like that can be like 2 or 1, depending on, you know, the course. But all right, so when you sign up for classes, at this college, you're going to pay $80 per credit hour, and then an additional $55 student fee. First question, what is the one-time charge, or what we call the fixed cost? So what are you going to pay no matter what? No matter how many hours you take, what are you going to pay? The student fee, $55. And every college has a fee just to go, no matter how many classes you take. Okay, so part A is $55. Okay, part B. What is his variable cost? What are they talking about? Have they even mentioned a human being here? The tuition. Okay, so, well, yeah, I guess it's assumed. Can't assume that. This 2019. Okay, what is his variable cost? So variable means change. What is the changing cost? That's where the 80 comes from, right? The $80 per credit hour is the variable cost. Okay, part C, write a tuition function, capital T of X. So now what they want us to do is they want us to create a linear equation that would give you the tuition you're going to pay if you take X number of hours. So we already said no matter what, our tuition cost is going to be what? $55, no matter what, 55. But then plus what? 80, we'll use X, because the way they wrote it, they said T of X, this means that X is the variable. So 80 times X, where X is the number of credit hours we take. So if we take one class, right? That's a 3-hour credit, like this class. Then we're going to plug 3 in here, right? And that would be our cost. If we took a full semester load, 12 hours, then we would plug 12 in here. Make sense? Okay. Any questions on that? All right, part D. How much does it cost to take 9 hours? So what do?
80 times 9.
Yeah, so we're going to replace the X with 9, right? That's what we're doing. So really, we're doing, like from last class, we said that when we have a function, we can plug something into it, right? If we had f of x, I could say, what's f of 2? You'd plug 2 in for x. Here, we want to plug 9 in for x. And then remember your order of operations. You must do the multiplication here before you do the addition. So 80 times 9, I believe that's 720. Right? Is that right? Yeah. Okay. And then add those together. 775. And this is money, right? So $775 to take 9 hours. That seems low. Okay, good? Questions? How about part E? What's the difference between part E and part D, the one we just did? What's the big difference? Yeah, they're giving you what the total cost is, right? They're saying, hey, this student at this college, their bill for the semester is $1,095. How many hours did they take? So they're giving you this side, right? They're telling you that this is $1,095, and they want you to figure out what this is, but leave this as X. So they want us to solve for X. Let's write it down here. So part E, what we know is that 1095 must equal our 55 plus 80x. So we know at the end, when you plug in something for x, we should get 1095. So we just go through and solve this like we've been doing, right? Get x by itself. So what's our first step to get x by itself? Subtract 55. So minus 55 here, minus 55 here. Cancels. We have 80x still here. And then what's that over there? 1040? And now you have to divide both sides by 80. So divide by 80. divide by 80. And what do we get? What's 1040 divided by 80? What is it? 13? Okay, so this is 13. And then these 80s canceled, so we just get x. So what's the answer to the question? 13 hours. They took 13 credit hours. All right. How's that? Do you think you can handle that on a test? Speaking of college and tuition and stuff like that, this is kind of off topic, but I think maybe it's worth a little bit of time. You all know what this is, right? You know what that is? GPA? I remember when I was a student in college, I wasn't a math major when I started college. I was actually architecture. That's what I wanted to do. It's a long story how I wound up in math, okay? But the point is, I didn't know how to compute my own GPA when I was in college in the beginning. Like, I didn't understand how it's done. Would you all like to see how your GPA is computed? Have you ever wondered how it's done? It's not hard once you understand it. Okay, so let's do a sample here. So let's say that first thing you need to know is that in college you have, I don't know of any college that doesn't use those letter grades. You know, some colleges use like A+, A and A-, B+, B and B-, but most colleges use A, B, C, D, F. So when you take a class, those are the only grades that can be assigned to you. What you need to know is that if you get an A, this is equivalent to a 4. All right? An A is a 4, a B is a 3, a C is a 2, a D is a 1, and an F is basically like you weren't there. It's a 0. All right? So let's say that a student, we're going to do a sample of 2 students. We're going to go student A, and student B. All right? And we're going to compare. Let's say student A takes a couple of classes. Let's say they take 13, 14, which is this class, right? Let's say they take, I don't know, someone taking a class that they want to share, that know the number for it? No? 2306. What is that?
Psychology.
Psychology. Any other courses? No? I'll just make up my own then. 1320, okay? And let's see, they're not full-time quite yet, right? Let's make them full-time. So let's give them one more class. Let's just go with, what? 349, okay. All right, so the most important thing here is this number right here, right? That gives you your credit hours. You all with me? Now, let's talk about the grades they get. All right, so let's just make up some grades here. Let's say in this class they get a B. How'd they do in psychology? A+. Okay, A, I'll do A. Let's say in this class, not so great, okay? And in this class, let's say that they get an F, all right? Okay, got it? Now, let's look at student B. Student B took 2412, which is pre-calculus. They took, I'm going to make something up here, 2418, which is some other course. Then they took, what are we at, 8 hours? They took 1201, which was like a physical education class. I'm making this up, all right? And then maybe they took like 2204, which is, I don't know, basket weaving or something like that, okay? And let's now give these students the same grades for these, all right? So let's go B, A, C, F. They failed basket weaving. It was tough. It was a tough class. Yeah. Okay, so these students will not have the same GPAs. Even though this student took 12 hours, right? 3, 6, 9, 12. This student took 4, that's 8, right? 10, 12. There's 12 hours here. They got identical grades. They will have different GPAs. And here's why, okay? This course right here is equal to a what number? So you go over there, B, that's a 3, right? This one is a 4. This one is 2. And this one is 0, right? So same thing here. We have 3, 4, 2, and 0, right? The next computation is the most important one. What you do is you take the credit hours right here and you multiply it times the grade. So what's 3 times 3? 9. That's I forget what they actually call that. Let me think. It's just slipped my mind. They got 9 there, and then what about this one? 12. This one? 6. And this one? 0. The F's are killers, okay? Because no matter what this number is, if you get an F, it's a 0. Like it's like you weren't ever there, and it messes up all your average. It contributes nothing to your GPA. Okay, now let's look at this one. What do we have? 12, 16, 2, 4, and then 0, right? Okay, now let's add these up. What does this student get when you add that up? Is it 27? 18? Yeah, 27 here. Okay, and then add these up. 32. Okay, so you add these up, you get 32. Go with me? We're almost done. We're almost done. Now, you take this number and you divide it by how many hours the student took. So how many hours did this student take? 12. So I take 27 and divide it by 12, which I'm going to put down here, hours. And I'm just going to put here total. And someone on their calculator do 27 divided by 12. 2.25? Okay. Now, this one over here is 32 divided by the number of hours, which was 12. Someone do that for me? 2.66. Right? So if you look at this scale here, you know, if this is 0, 1, 2, 3, 4, then a 2.25 is like just a little bit above a C, right? A 2.66 is closer to a B than it is to a C. Does that make sense? So what matters in your GPA, of course the grade matters, okay? If you get A's, that's great. If you get D's and F's, that's not great. But the more important thing is how many credit hours was it worth? So look at this student. They failed the course, right? But it was only worth 2 hours. They failed the course, but it was worth 3 hours. This student got an A in a course that was 3 hours, right? That's good. But this student got an A in a course that was 4 hours. So it's worth more. So the higher the hour of the class is, the more impact it's going to have on your GPA. So if you fail basket weaving, it's not going to destroy your GPA. But if you fail pre-cal 4-hour credit, that's going to have a huge impact on your GPA. Does that make sense? I hope that clarifies how GPAs are computed. You can do this for each semester. You can look at your GPA, or you can just do all your classes that you've ever taken. Just add up all the, do your letter conversions and then add them up and then divide by the total number of hours and you have your GPA. That's how they compute it, and if you go online you can see your own GPA. They calculate it for every semester. But yeah, anyway. All right?
So how are the two semesters averaged together? Like how does that work?
They just do it like, let's say just basically take both semesters and put them all into one pot and then just do the same thing. So they don't average 2 semesters. They don't look at it like you did 2 different semesters. They look at it like, how much have you done? And they just take all the classes. So they just let's say we had 2 semesters worth of stuff. They would just make a new list with both semesters in it and do the same things I just did. Yeah, so you don't average semesters. You look at every class individually. Now, if you fail a class, and this is where things get a little tricky. If you fail a class, some colleges will allow you to retake the class and then they get rid of the F. Okay? So like, let's say you take 13, 14 and you get an F. Of course, we know that's a 0, right? But let's say you retake it. And let's say you retake it and get a B, which we know is a 3, right? Some colleges will say, you never took that. You were never there, okay? Other colleges will say, okay, 3 times 0 is 0. 3 times 3 is what? 9, right? Add these up. What? 9. Okay, take that number and divide by what? Total number of hours you took, 6. And 9 divided by 6 is 1.66. So basically, a student who fails and then retakes and gets a B, it really goes into their GPA as if they got a 1.6, which is like below a C, right? You should know that when you transfer to a university. Are they going to take this out like it? Because if they take that out, what's your GPA for this class? A 3. It's a 3. But if they average them, it's that, and that's not good. So, all right. It's very difficult to recover a bad GPA. It's very difficult. Yeah, I mean, because no matter what you do, you can't erase the bad courses. You can't get rid of those. But it's not the end of the world. But the problem is that a lot of programs, that's the first thing they look at, right? Like even to get into the program, you have to have a minimum GPA. And if you don't have that GPA, they won't even look at you. So how can you bring up your GPA? Take courses that have a lot of credits and do well. Don't take basket weaving and get an A. It's not going to impact your GPA that much. Okay, here we go. Joe has a part-time job. Good for Joe. He walks dogs. Wow, okay. It's crazy that that's a job. All right, so Joe has a part-time job caring for and walking dogs. He estimates his annual insurance, and I guess et cetera means other costs, is $420. So I guess because he's walking people's dogs, he decided to get an insurance policy in case he's on his phone, not paying attention, the dog gets away, gets run over by a car, he gets sued, he has insurance, okay? So he's going to pay $420 a year for insurance for his business. On average, he spends $4.50 on gasoline every single time he goes to take care of a dog. He figures costs about $4.50 for each job to go drive there and come home. Yeah, it's expensive, yes. He charges $15 per visit. So that's what he charges the customer. So it says, note that this is an annual cost function. And the reason it's annual is because this cost is annual. What is the one-time annual charge or fixed cost in this problem? $420. That's how much goes out, right? No matter what, if he's going to keep doing this as a business, every year he's got to pay the $420 for the insurance, right? What is his variable costs? Variable costs. The $4.50 a gallon. I mean, not a gallon, not a gallon. It wasn't per gallon. It was per trip, right? So that's variable. The $4.50 per trip or per job, or however you want to say it, per job or per visit, right? The reason it's variable is because he doesn't know how many jobs he's going to do in the year, right? So that cost might be, if he only does like 10 trips in 1 year, or 10 jobs in 1 year, it's a certain cost. But if he does 100 jobs, then it's more, right? So that fluctuates. So now we want the cost function. How much does it cost him to run his business? It's asking for the cost. Notice it's not asking for how much he makes, right? How much does it cost him, right? How much does it cost him? Well, the cost is what? It depends on x. What's x going to be for us? What is x going to represent? The number of trips or the number of jobs he does, all right? So what is it? $4.50, right? Times x, that's how much it's going to cost him for each visit, right? And then plus how much? The $4.20, which is going to be there no matter what happens. That's his cost function. Now, what about the 15?
That wouldn't be in their cost function. Right?
That wouldn't be in the cost function. See, a cost function is only talking about the cost. It takes, what it costs him to run his business. Now, this is not a business class, so we're not going to get too deep into it, but we do have in business what would now be referred to as our profit function. So your profit function is the function that tells you how much money is coming in. So can you tell me how much money will come in? It depends on x. It depends on how many jobs he does, right? So what would it be? 15x. And notice that this one doesn't have a fixed anything. Like he's not going to make $200 every year just for having his business, right? There is no plus some number here.
I thought it was,
Right? Okay. So, pardon? Minus.
Because profit is how much you're making, and he's losing $4.50 every time he does a trip.
Okay, so let's see. I don't want to go too much into business because I'll freak everyone out. Okay, maybe we should talk about it then. When it comes to these models for businesses, you have three functions. You have the cost function, you have a profit function, and you have a revenue function. Okay? So what do those words mean? Cost is the thing that tells you how much money is going out. Okay? Revenue is how much money is coming in, and profit is the difference between the two. Okay, so technically, this should be a revenue function. I didn't want to get there. I didn't want to go into this because it would just confuse people. But this is actually revenue. Okay, it's the money coming in. The profit is the difference between the two. All right, but this is all I want you to do. Let's just stay here. Okay, this is Math 1340. We're going to just stay right here. All right. Moving on. Let's skip 6. Okay, this is interesting. In 1990, long time ago, Americans ate out, that is, ate meals at restaurants, an average of 143 times a year, I guess? Yeah, they didn't put that, but I guess there's some in 1990, maybe. That seems high or low?
Low.
Does that seem low? 365 days a year. Americans eat out like, no, I don't know, that just seems really high to me. I guess it depends on what you do, right? Like, if you've got a family with, 3 or 4 kids, it's going to be very expensive to go eat out 3 times a week.
You have to think of all the bachelors.
That's right. I mean, then you have to think about everything, everyone else. So maybe that does work out. Who knows? But I can tell you, if you do eat out that many times a year, once you have a family and kids, you will not be eating out that many times a year. Okay, so by the year 2000, this had reached 170 meals out a year. If there is constant growth, how many meals a year do you expect us to eat out in 2030? Okay, this problem is very different than anything we've done. All right? So let me show you how we're going to do this. All right, so I'm going to use a graph here to get this started. I'm going to say this is time in years. And then this right here is the number of times Americans eat out per year. Okay, so my time axis here, I'm gonna start with the first piece of information I know, which is in 1990. So I'm just gonna mark a spot here, 1990. How many times did people eat out a year there? 143. So I'm just gonna go up, put a dot here, and I'm gonna mark it over here as 143. Does this graph make sense? And then in 2000, which would be, somewhere over here, 2000, that jumped up to what? 170. Now, the important part here is it says if there is constant growth. That means if what's happening is that it's changing at the same rate over time, then we can assume that there's a line that goes through here. And what we're trying to do now is predict in 2030 where we'll be. Does that make sense? Yes? Sure? Okay. So, how can we get this line? How can we get this line? This is going to be somewhat challenging. You have 2 points, don't you? These 2 points? Can you tell me as an ordered pair of numbers what those 2 points are? What are those 2 points? So what's the x-coordinate of this point? 1990. And then what is the y-coordinate? Sorry, I'm pointing here. What is the y-coordinate? 143. And then the x-coordinate here is 2000. And then 170. If you have 2 points on a line, what can you always give me? The slope, right? So we can find the slope of this line. What would the slope of this line be? It's the formula. Other way around, yeah. So remember the slope is y2 minus y1 over x2 minus x1, right? That's our formula for slope. So we have to label these. Let's label this one x1, y1, and this one x2, y2, and then plug everything in. So what would be the y2 here? What's y2? 170. Take away 143. Then all of this over 2000 minus 1990, right? And let's compute this. 170 minus 43, 27. 27 over 10. Y'all okay with that? That's our slope. Now let's see if we can't interpret what the, I almost cussed, sorry. This means it's 27 over 10, right? 27 was these numbers, right? These numbers are how many times people go out to eat. And these numbers were years. So isn't this telling you that it's increasing by 27 every 10 years? Do y'all see that? I'm using the slope to tell me what's happening every 10 years. It just so happened that it's over 10. Had this been like over 8, then you would have to say like 27 every 8 years. But it's 27 over 10. And that's convenient because how many groups of 10 years is it going to take for us to get to 2030? 3 groups, right? We want to predict 30 years out. So all we have to do is multiply the top and bottom by 3. Does that make sense? If I take this number and I multiply the top by 3 and the bottom by 3, then what's 3 times 27? 81. So this would be 81 over 30, which would mean that it increases by 81 every 30 years, right? So where were we? At 2000, how many where were we at? 170. But this is telling us that in 30 years, it's going to go up by 81. Does that make sense? It's a little tricky, but I mean, this is the way we can do it. So what can we predict here as, you know, the number of times people are going to eat out? It's 2, what is it? We're adding 81 to this, right? So what is that, 251? We're adding 81 to 170. So this number we get by taking 170 and adding 81, and that gives us that number, 251. So in 2030, people are going to be eating out 251 times a year. I don't know. I don't think that it's realistic to use a line. Do you? Like, I don't think that a line is a good model for what's happening. Because won't you eventually get to a time here where the number of times people go out to eat is more than the number of days there are in a year? Like,
Yeah,
wouldn't,
there's 3 meals a day, so.
well, it doesn't break down the meals. All I'm saying is if this keeps going up by 81 every 30 years, then eventually this number is bigger than the number of days there are. Yeah, you could say, I guess, 3 meals a day, but even then, eventually you're going to get, that number is going to never stop growing, right? But who cares? What do you think? Where does our timeline end? What do you think we got? You think we got till 2030? I think we're going to make it to 2030. What do you think? You don't think 2025? Really? Okay.
Depends on what it's for.
Depends on what?
On what it's for.
Yeah, that's what I'm asking you, though. I mean, you think we got 50 years? Y'all think we got 50 years? As a species on the planet, you think we got 50 years? Hope so.
I'll let my kids deal with the
With the mess?
yeah.
Okay, that's it for those word problems. We're ready to move on to mixture. Wow. I get frustrated when I start thinking about the world. I'm sure you do too. I don't know if you know this. My daughter has to do a report on the sun. And so she has to have all these facts about the sun. And so I'm telling her, you know, that our sun, this is our sun, okay? And this is us on planet Earth. Our sun is obviously a star. I hope everyone's okay with that. So our sun is a star, and of course there's millions of stars, right?
I think you drew the Earth. It's supposed to be flat.
Oh, it is flat. You're right, but we're looking from the top down.
Okay. Well then,
The sun's flat too? Okay. So our sun is a star, and there's millions of stars. And some stars are really big, some stars are really small. You know, you've got ones that are kind of like orangish, and some are kind of bluish, and some are white. And you know, ours is just kind of an average star. It's about right in the middle in terms of its temperature. It's right in the middle in terms of its size. So it's pretty much an average star. But average stars, they all go through a lifespan. They all are born, and then they all at some point die. And one of the first steps to a star dying is that it expands. Okay, so it actually gets bigger. So at some point, not 50 years from now, but at some point, our sun will expand to a point where life on Earth will not be possible. Like, it'll be too hot here. Okay, so definitely, I'd have to go back and do some research on when we expect that to happen. But there is a definite end, okay? Pardon? I don't know. I'll have to go back and look. I don't think it's 3,000 years out. I think we're a lot further out before it expands. But I'll go look it up, okay? Now, I don't think we're going to make it that far. Like, I personally do not think humans are going to make it to where the sun expands and takes us out. Like, I just don't think we're going to make it that far. So the reason I'm bringing this up is because what really frustrates me is that if we know that we eventually have to get off the planet to survive, right? You have to get off the planet to survive. And we're not going to get like, we're not bringing in any faith or religion or anything here. We're just looking purely scientific right now. If you know the sun's going to expand, you have to get off the planet, right? What does it take to get off the planet? Well, you have to put money into research into physics. You have to put money into a lot of different STEM fields, large amounts of money to try and figure out how the hell do you get off the planet, right? So here's what frustrates me. I'm reading yesterday that some baseball player just signed a $250 million contract, right? Like that's just crazy, okay? There's a pitcher right now, I don't know his name, but he's one of the highest paid pitchers, and I calculated it. Every time he throws the ball, he makes $18,000. Stands up on the mound, does his little thing, $18,000. Stands up on the mound, $18,000, right? My point is, our priorities are all in the wrong place. We're willing to pay millions of dollars for sporting events, sporting entertainment, athletes, right? But when it comes down to like everyone's scrambling, shit, we're screwed, you know, and it's too late, we can't do anything, you know, well, you can only blame your own society for what it holds as a priority. So I'm not sure we'll ever get to the point where we take it seriously. I doubt it. I used to believe in mankind a little more. I kind of have lost hope. So, but I always hope that the younger generations will still, you know, want to have that future. I just know I was a physics major before I was math, and I realized that there wasn't money in there. Not money for me to be made, but there wasn't money in for research. So it was really hard to see where you could go with it. Yeah. Anyway, sorry to be a bummer.
Have you ever seen Titan AE?
What is it called?
Titan AE.
Titan AE? No, I have not.
It's an animated movie. You should watch it.
Titan AE. Okay. I'll try and remember. Well, it's on video, so I'll go back. All right, let's do some mixture problems. That sounds fun, right? All right, so solving mixture problems. These usually cause students some trouble. All right. But I think this is pretty like applicable to the real world. Mixing, let's say you mix 1 gallon of 100% apple juice with 1 gallon of water. How much total liquid results, and what percent is actually apple juice? All right, let's start with that question. And I'm going to draw some pictures because I like pictures. Here's 1 gallon. All right, I have 1 gallon, and in that is 100% apple juice. 100% apple juice. Then I have another gallon, 1 gallon. And how much percent apple juice is this?
0.
I'm mixing with a gallon of water, right? So this is 0% apple juice, isn't it? So the percent here, I'm talking about apple juice. Understand?
Yeah, I was looking at the second one.
Yeah, ignore this one for now. We'll come back to this one in a second, all right? So I'm supposed to mix those two together, all right? So let's mix them together. First of all, how much liquid results? 2 gallons. That's pretty straightforward, right? So when I mix them, pour them together, I have this new container. Of course, it's got to be bigger. And this is 2 gallons. Now, the question is, what's the percentage of apple juice? 50. That seems reasonable, doesn't it? And in this problem, that is going to be the answer. And I think most of us could just reason, well, if you mix these, it's 100%, 0%, you mix them together, you should get like halfway in the middle, right? But that's only because this is the same amount of liquid. This is 1 gallon, that's 3 gallons. Had this been like 10 gallons in 1 gallon, it wouldn't work that way. So let's try and figure out what math it takes to get to the 50%. So I want us to go back to the first one. If 50%, if 100% of this 1 gallon is apple juice, then this is going to seem so confusing. I want you to take 100% and multiply it times the 1 gallon. And this is going to tell you how many gallons are apple juice. It's going to seem crazy. Just do it. What's 100% as a decimal? 1 times 1 gallon. So how much of this gallon is apple juice? 1 gallon. I know, we knew that already, right? We knew that, but the math of this is important. So we know that we have 1 gallon of apple juice here. Now, over here, okay, we have 1 gallon. Take your percentage and multiply it times your gallon. And when you multiply 0 times that, you get 0, right? And that's how many gallons we have of apple juice here. Is that obvious? Okay. Now, what I want you to do is take these two numbers and add them up. I have 1 gallon plus 0 gallons, right? And divide that by the total number of gallons we have in the mixture, which is 2. And what would you get? 1/2, which as a decimal is 0.5, right? Which is where you get the 50% from. Now I know that math seems like crazy. Why would you need to do that if we knew it was 50%? Well, let's look at the next problem, and let's see how we can do the same computation to get to the answer. All right? So let's look at the next piece here. What if you mix 3 gallons of juice? So we're going to change it up, right? 3 gallons of apple juice with 1 gallon of water. So this time we have 100% apple juice, but we have 3 gallons of it. And then over here we have 1 gallon of water.
So is it 300%?
Let's see what it is, okay? We have 3 gallons here, right? So we take 100%, we multiply it times 3 gallons. 100% is 1, so we have 3 gallons here, right? Okay, here, same